Hi, I am Kaushik Varanasi and I am from Raghu Engineering College. And firstly, I would like to thank MX3 for giving this wonderful opportunity for learning a lot of things on IoT. So coming to the contents, here the internship program was divided into 4 weeks, and each and every week they have trained us with a new topics which are important for us. So and after that we did a project. So, firstly, in the first week, they learned us C programming from the scratch, and it is very easy. It can be easily understandable for the people who are very newer to this. So, this is the first code, basic code for printing the hello world. From as I told, from the scratch they explained. So here we can see it is um, structurally programmed. So next, in the topics learned in C programming are data types, modifiers and qualifiers, conditionals and loops, operators, arrays and pointers, strings, functions, storage classes, preprocessors, and so on. And, and coming to the Internet of Things, they learned us a lot, and with the help of some real life examples and all. By explaining with the real life examples, we got to know properly what and what. So here are some of the applications of IoT. So coming to the healthcare department, we are having wearable health monitors and so something like that. And automobiles. Coming to automobiles, smart cars, logistics and transports means smart buildings like that. In businesses and home automations, and these all are the some applications and examples of Internet of Things. So coming to the embedded system. Actually, embedded system is an combination of software and hardware, which is used for doing a particular task. So generally, they compromise of a processor, power supply, memory, and communication ports. Here we can see sensors, analog to digital converters, processor and ASIC, digital to analog converter, actuator, memory. This is the structure of the embedded systems. So in this way, the embedded systems are working. And here are the some of the examples of embedded systems. Here we can see in the street lights, smartphones and smartwatches, and MRI scans, washing machines, inverters. Not only one thing, many things we are using. In our daily life, we are mostly using these all, no, as we know. So. Microcontroller. Actually, microcontroller is a part which is used for controlling the devices like peripherals. Here we can see ADC block and DAC block. It contains ADC block and DAC block, timers and counters. And one most thing is in microcontroller, it provides PWM, pulse width modulation. So the signals in the coming from the microcontroller are pulse width modulated waves and processor memory and IO parts, IO ports, memory, microprocessors versus microcontroller. So here there is a small difference between the microprocessor and microcontroller. What does it means? In microprocessor there will be no peripherals and memory, these all. Coming to the microcontroller, we can see that all are So, coming to the project overview, this project provides IoT-based home automation solutions using Arduino Uno board in PixM Lab simulator. To control remotely, the device was used a app named Blink IoT, which is a cloud-based app. Uh, that is, we can control from anywhere using the internet. We automated the garden lights where they brightened according to the sunlight, and temperature control system is automated. Last and not least, the water tank is also automated by controlling the inlet and outlet valves of the water tank respectively. And coming to project objectives, collect all the discussed home appliances to Arduino and integrated it with the Blink IoT app and cloud. It means all appliances which are needed to simulate are collected and simulated in a Pixem Lab simulator and obtained some critical notification regarding temperature and water tank on the Blink IoT apps and check the real-time status of the temperature and water level of the Blink IoT app in some using some LCD screens and dashboards. And also to control the garden lights automatically. So coming to needs, which what are the needs for home automation means mainly we need a microcontroller along with a Ethernet chip and also Blink cloud server and also a Blink mobile app. So in this figure we can observe that there is a home and after that the peripherals are connected. I mean, the home automation uh, peripherals are connected to the microcontroller, and then the microcontroller is connected to the cloud server, and then it is connected to the mobile application, vice versa. So here in home lights and these all are controlled by using this microcontroller and along with these cloud applications. So coming to Arduino Uno, as earlier I told about Arduino, this is an Arduino board which it contains a microcontroller called Atmega 328P. P is known as programmable and it has a 14 digital pins. Here it will be and it having six output pins used as a PWM outputs and six analog input pins and another thing is it is a 16 megahertz ceramic resonator and it contains a USB connection, a power jack on ICSP header and a reset button. Arduino Uno board can be programmed using various IDs. And we used in this project is Arduino IDE. It is the basic IDE which were used by every people basically. And coming to Pixim Lab and Blink IoT app. Pixim Lab is in the name itself. It is saying that it is a simulator. So we can feel all the I mean experiments in the simulator. Um, it is a very good tool which contains all the development boards and along with many connections and all. It is easily usable, so it is user friendly and PixemLab is an open source real-time emulator. So we can find it for open sourcely And coming to Blink IoT app, it is an already I told you Blink IoT is an cloud platform which is used for controlling the IoT devices. It is an user side application. It means like client side application where the client is used to give the instruction through the particular IoT Blink application, and then it will connect to the cloud server, and then the cloud will connect to the ethernet chip and Arduino Uno, and then it gives the response to the home. So LDR, coming to the components, LDR sensor is known as a light dependent sensor. LDRs are tiny light sensing devices, also known as a photoresistor. And LDR is an resistor whose resistance changes as the amount of light falling on it changes. So that is the resistance of the LDR decreases with an increase in the light intensity. This property allows us to use them for making light sensing circuits and these all. The LED lights are connected to the LDR via ADC. The ADC converts the analog input by LDR into its equivalent digital form, which is converted later by certain formula for 0 to 255 as upper bound. Based on that, we glow the LED. So coming to the garden lights control. Here, we can see this structure, which is this is an Arduino Uno, and this is a LDR sensor. It is an lights. It means the properties of LDR sensor are applied to accomplish the controlling of garden lights during the day. The outdoor lights is maximum so that LDR sensor detects the light and the garden lights is turned off. Whereas at the night the outdoor lights is very low so the LDR sensor detects the light and the lights is turned on. So in this way the garden lights are controlled using the LDR sensor. So here the LDR sensor played a great role in controlling these lights which are in the garden. And not only in the garden, we can use these control system at anywhere which is helpful for it means like it is helpful for people less controlling. Yeah, coming to temperature sensor. The temperature sensor is recorded using LM35 sensor. Um, which reads analog values. The value is converted into binary values, and the latter actual temperature is calculated using the obtained value of voltage. This sensor doesn't require any external calibration to provide accuracies in results. So here it doesn't require any accuracy because automatically it can sense the temperature and it will give the reading as a binary value to the particular microcontroller. So, so with the help of temperature sensor, so the temperature control system was designed. So here we can see this is an Blink IoT app, and here this is Arduino Uno. This is CLCD. CLCD means it was a LCD display, which is used for observing the readings and this all. So this is the temperature system. So as we know, already I told temperature system means here the temperature sensors and these all are used to control the heaters and coolers and accordingly. So here the temperature system will transmit and receive the data through the microcontroller, which is called as Arduino Uno. And this Arduino Uno will sends the notifications of temperature and all. And here, actually, the user, actually we, the people, will use this Blink IoT app and control these temperatures and these all. These information is transmitted into controller and then to these peripherals. So here we can see the temperature control system consists of heating resistor, an LM35 temperature sensor, and a cooler. So, and this analog values of temperature is obtained from the temperature sensor LM35. As earlier I told that LM35 gives a binary values. So, this binary analog values are converted into digital values using ADC, and the control the temperature of the systems by turning on or off the heater and cooler through the blink IoT app. The features of this system is that as the temperature reaches 35 degrees Celsius, heater turns off automatically to avoid more heating. The notification of the same is displayed in the terminal of Blink IoT app, and along with that, we can observe this in CLCD. And and the next project is water inlet and outlet valve control. This busy life, people are used to control the water system through this IoTs because it is very efficient one to save the water. That is the main reason for this project. Here we can see it reads the volumes of water in the tank through the serial communication and display it on the CLCD. So the user can watch the thing on. I mean, watch the reading of the volume in the CLCD. So here we can see this is the CLCD. This is the Arduino Uno. This is the water tank. And here the volume of the water tank will be information will be transmitted to the what is this Arduino Uno, and inlet valve control and outlet valve also control using this Arduino Uno. The control the volumes of water in the tanks by controlling the inlet and outlet valve by sending the commands through the serial communication. Display the volume of the water in the tank on the CLCD and also the Blink IoT app. And here have we know that here we can use automatically turning off the inlet valve and outlet valve, and also we can control it manually by watching the readings of the volume of water. So in this way it was working. Anyways, the Blink IoT app was playing a great role in nowadays because they are providing cloud sources for us for using these all things. So this is the simulation image. This is the CLCD. Here we can see the readings of the this water tank volume. Here we can see 3000 liters volume it having. So the inlet valve is turned off. So according to the volume of the tank, the inlet valve off and on will be going to be done automatically. So here is the port. I mean, this is not a serial port. This is a water tank model. This is an inlet valve and this is an outlet valve. Accordingly, it was controlled. This is the sensor which is used to measure the volume of the water tank, and from the bottom and top. Here, it senses the water if the water is going to overflow, and if it reaches a particular capacity of the volume, particular capacity of the tank, then it is going to turn off the inlet valve and turns on the outlet valve for utilizing the water. So and also along with that, this is the LDR sensor. As I to explained a project which is used for controlling the garden light. So this is the LDR sensor which is used for sensing the sunlight and control itself by um, using a Arduino board, and it the Arduino board sends the commands to the peripherals called as LED lights and these all. It is used to these are the LED light strip, and we can see uh, this light was turned on as the temperature value is 34.18 Celsius. So the light was turned on, so accordingly it was operating. And so according to that, there will be a control system, temperature control system. These all are works with this. So this is the Arduino board, and this is very mostly used. So I conclude that by using the Blink IoT application and PixSim Lab simulator, we have simulated the home automation where LEDs, temperature system, serial tank resembles like a light, heaters, coolers, and water tank in the real time. CLDs acts like a dashboard used to display the events widgets from the Blink IoT app, and it was very helpful for me. Hence, the project provides the perfect solution for home automation. So, one of my friend will demonstrate the project which has been done during the internship. Thank you.
So this is the Arduino IDE user interface where I have written the code for home automation project. We have created separate files as they are easy to maintain, and we will look at each of them one by one. First of all, this is the home automation main file. It consists of the Blink authorization token, device name and template ID which we get when we register the device on Blink IoT cloud platform. These are some preprocessor directive which we need to include in order to use Blink as well as to use the CLCD display. This is the function for the cooler pin which we display on the Blink IoT app in order to control the cooler. This is the code for the heater pin. Similarly, these are the codes for inlet and outlet valve of the cereal tank. We also need to display the temperature on the Blink IoT app. Hence, this is the code for the same, where we display the real-time temperature reading. We need to handle the temperature, that is when it is above 35 degrees Celsius, we need to turn off the heater. We also print the notification on the Blink app with the following code. We also need to control the water volume above 2000 liters. Hence, we create a function called as handle tank. It checks if the volume of the water is less than 2000 liters, then it enables the inlet valve. If the tank is full, then the inlet valve is turned off. Now, this is the setup function which is called only one time. So we initialize the LDR, that are the guidance lights. We also initialize the CLCD display, and we also print information on it. Then we call the temperature system, and we also initialize the serial tank in the setup. Next, this is the loop function which call all of these functions written in it repeatedly. Moving on to the next file. This is the garden light file. It consists of a function of initializing the garden lights, and it also consists of a function to control the brightness. When there is a daylight, the LEDs are turned off. And when the brightness is low, that is when it is evening and night time, the brightness of the LEDs increases. This is the LDR header file where we define some macros for the LDR sensor as well as for the garden light pin. This is the main header file where we define macros for on and off. We also define macros for the inlet outlet pins, cooler and heater pins, water volume gauge, blink, terminal pin, and temperature gauge. Next, the serial tank file. The serial tank file consists of a function of initializing the serial tank. Then we define a volume function to get the real time status of the volume of the tank. We define a function to enable and disable inlet and outlet valve respectively. This is the serial tank header file. It consists of the inlet and outlet valve macros defined, also macros for high float and low float for volume to enable and disable. This file is for the temperature system. We initialize the temperature system. We read the temperature from the temperature system using this function. This is the cooler control and heater control function respectively. At last, this is the temperature system header file where it consists of the macros for heater and cooler pins where they are connected to the Arduino Uno board, and also for the temperature sensor a macro is defined. So this is the PixSimLab user interface. If we are in the spare parts window where we have arranged CLCD display, as you can see it is displaying the temperature as 27.34, which is the normal room temperature. The volume of the serial tank, which is currently 3000, that is the tank is full and the inflow is off. This is the LDR system. These are the LEDs, garden lights. This is the Ethernet used for internet connection of the Arduino Uno board. And this is the temperature control system. It has the inbuilt LM35 sensor. This is the cooler and it has an heater. This is the Arduino Uno board through which these different spare parts are connected. This is the serial tank which is connected currently to the serial port COM2, and as you can see it is currently full and the inflow is off. This is the outflow. Next I will mirror my phone to the system and we will control this home different home components using the mobile phone and Blink IoT app. So as you can see now I have mirrored my phone. This is the Blink IoT app user interface. This is the cooler pin, heater pin, real-time temperature reading. This is the notification terminal. There are two tabs, tab 1 and tab 2 respectively. Tab 1 is for the temperature system. Tab 2 is for the inlet and outlet valve, that is for the serial water tank. Here the volume of the water tank, that is what is the current volume is displayed. As you can see it is currently 3000 liters. So first we will try to control the temperature system. We will turn on the heater and check if the temperature reaches 35 degrees Celsius, whether the heater is getting turned off automatically or not, and whether we are receiving the notification for the same or not. So as you can see, the temperature is increasing. As soon as the temperature reaches 35 degrees Celsius, we receive the notification that the temperature is at above 35 degrees Celsius and turning off the heater. Now we will turn on the cooler. When we turn on the cooler, the temperature decreases and the fan starts rotating and it tries to maintain the normal room temperature. We will turn on the cooler now. Next, we will check the serial tank. So as you can see, the serial tank currently it is full and the inflow is off. We will try to turn on the outflow and check if the level is less than 2000, whether the outflow is getting on or off. As you can see, the outflow is on now. Notification for the same is displayed on CLCD. and the water level is also decreasing. When the water level is less than 2000, the inlet valve is turned on automatically and it tries to maintain that water level. We will turn on the outlet valve and the inlet valve will now fill the tank, and when it reaches 3000 liters, it will turn off automatically. As you can see, the inlet valve turned off automatically. We will check our notifications. As you can see, when the water level was less than 2000, we received the notification and it turned on the inlet valve. When the tank is full, we also received the notification and it turned off the inlet valve. Now the last system, that is the garden lights. This is the LDR sensor. When the sunlight is maximum, when the sunlight is maximum, the garden lights are off, and when it is nearly evening or night, then the garden lights are brightest. That is the light are turned on automatically. So this was the home automation project. Thank you.